So this is going to be a little bit technical, so I apologize if some people zone out, but yeah. How do I do that? Oh yeah. Okay. Okay, is that better?
Yeah. That's great.
Okay. We'll do something like that. Okay, so I thought we'd just quickly show the dynamic factor analysis that I used in the papers I presented yesterday. Before I start, on the shared folder, that's on the Google Drive. So in the folder model code, there's the folder dynamic factor analysis, and on there I've put the code that I'm showing to you now, and there's this corresponding data, the von Bertalanffy estimate and the temperature data. I've also put on there so the description of the Mars package, the R package, which contains the dynamic factor analysis, and this user guide. This user guide is actually really well done. That's the one that I used. If I download it. Do you know her?
Oh yeah, from Seattle.
Okay. Yeah.
Don't know from Seattle.
I wanted to scroll down to the dynamic factor analysis. Can I search here? Page 121. Okay. Okay, so that's the PDF I put the user guide that you have now on the drive. That's pretty much what I followed back when I was a student to write the paper. So it's got the explanation of all the statistics. Can I zoom in on that as well?
Bottom right.
Bottom, yeah. So it's got the explanation of all the statistics, and it's got this example of code. So if you type this into your R console, the example of the code will show up. And basically, so you've got the explanation, and this goes together with so the piece of code that you have to run, and then the graphs that will appear. So you can basically follow step by step, and it makes it very easy to understand. So if you want to look into that analysis, read the user guide, and it's I find it quite very convenient for what I did. Before I forget, dynamic factor analysis I think was pioneered by Amazu, which wrote this book. So I brought it if someone wants to have a look. But, this belongs to Tara, so don't lose it, so I'll be in trouble. Okay, so this is the piece of code that I wrote for my analysis. I actually had to update it because when I did this analysis, I used a Mars package that was published in 2012. And so last week I downloaded the latest version, and of course all the functions have changed, so I had to update all the code. But so first I'm gonna load my data. These data that I put on the drive, these are the time series of von Bertalanffy parameters. So to get those parameters, I had to extract the englength key, fit the von Bertalanffy, raise the englength key as well prior to fitting the model. I didn't put the script I use to do that, but I've got it if you're interested. To run the analysis, you need to standardize your data. which I did with that piece of code, and then put it in the correct format. Oh, crap! Sorry. And to click on there. So that's what it looks like. So for each one of those columns or the substocks I showed yesterday, so 1, 2, and 5, 6 are the ICS area, 1 and 2 and 6. So 1, 2 means the northern North Sea, and 5, 6 the southern North Sea. And I've got a time series from 1970 to 2008 for each substocks. That's what the data look like. To input it into your DFA, you actually need to transpose it. That's the way the data needs to be inputted in the model. And if I plot my data, so this is what I showed you yesterday when I showed all the time series. The only difference here is that it's on a standardized scale. So you can see that the variation in elephant is more or less the same for all species. The number of this parameter NTS is the number of time series. So here I've got 13 because I've got 13 substocks. I'll come back to this later. This little control list is the maximum number of iterations that you want to use for your model to converge. And when you run your dynamic factor analysis, one of the things you can change is the what type of variance covariance matrix you use. So you can try all these different ones. To run the code here, I only chose one, which is the one for my base model. The reason for that being that if I run everything, it's going to take half an hour to converge. So yes, I'll run that. The next is how many trains do you want to test? So here I've got 13 time series, and we are looking for common trends. So there's no point in running a model where you look for 10 time series, because it's if you have 10 common trends, it's pretty much you don't have a common trend. So that parameter m is what is subtracted to the number of time series. So my best model that I showed yesterday had 2 common trends. So basically 13 minus 11, I've got 2 common trends. And that is a bit of code that run the dynamic factor analysis. Okay, so this is what I was worried about.
Like when you do a PCA,
Yeah.
I mean, you can make like a screen plot and tell you how much variance is accounted for by each of the factors. I mean, so like when you do PCA, you don't usually have to tell how many factors or how many components you actually want to estimate. It just does them all. But this is a little bit different. Yeah, I mean, you can. You can run all your common trends. The only thing that it would take a long time to run. And okay. Yeah, someone.
Well, and you can also calculate the proportion of variance explained by each factor and do like a scree plot, like they sometimes do in factor analysis.
Yeah. Okay, so I just have to address the error. Access is denied. Oh, crap. I think that might be because I'm not allowed to access, but it's got RStudio on there, so does anyone knows how to fix this?
Sometimes when I get errors like that, you have to. Do you have multiple R instances though?
You're running 64-bit R yet?
I've never used this computer before, so I can.
64-bit DLL.
You
doing that?
Sorry?
Doing it off the desktop, right? Are you?
Yeah.
Yeah.
That, But it's basically
Is KFAS a dependency of ARM? Do you need to install that package?
My suspicion is you're not running 64 by ARM.
okay. So how do I change that? Shit. Yeah, sorry about that. I didn't read from my laptop. The only reason is because the microphone is really crap, so people on Skype wouldn't be able to hear me correctly.
Okay.
It's 64.
Well, it seemed like the error was in KFAS DLL, which is another R package. It's a dependency. So install
Check
that.
that KFAS package is installed correctly.
Oh, and now RLang is another package that looks like it's.
Crap.
Yeah,
Hey, Paul.
Yeah.
I mean, are we trying to get through all this today? I mean, some of us will be leaving. I'm leaving, I won't be here tomorrow.
Okay.
I gotta leave in the morning. And,
Yeah, Ryan's gonna go over
I'm leaving in like 5 or 8 minutes. If you order a taxi, I'll go down. Yeah, that'd be great. 'Cause then I'll go down. It's 15 after 20.
Okay. One thing we could do is chat a little bit about the final report.
Okay.
We could sandwich that in while Tom's here.
Right, that's a good idea.
We'll be on his way out, but we just had a quick little discussion about it now. Maybe we just have that so that that detail is taken
Okay.
care of. Essentially, I think we're freeing up tomorrow a little bit, so that we don't have as much stuff to do tomorrow.
yeah, if there's any need for the final report to pull together, like metadata and stuff like that, it'd be important to know, you know, what kind of things we wanna pull together to augment the tables that are already
Yeah,
generated.
yeah, so I think we could have that kind of discussion.
Yeah, so I'm sorry, sorry to put you through this.
Is that a high wire act?
Yeah.
Running our code.
So do you think we should do that as soon as Alan's done, or?
Yeah, as soon as Alan's done.
Sometime R has in mind it, isn't it?
Okay.
Yeah, he's scheduled to 3:30, I think, so that gives us half an
Okay.
I could plug in my laptop on there and try to run on there.
Yeah, well, I think we should do that.
Okay, okay.
Okay, you want to try?
Okay. So Tim and Jim, you guys are dialed in.
Yeah.
There might be a.
Yeah, we've got the,
So Tim, are you online, Jim?
Which one is it?
I'm trying to finish my text for you. I was gonna give myself 2 more minutes, but I'm gonna just walk in.
so early.
Yeah. Did the taxi come
Yeah.
with a call or does it come with
Yeah.
No, I didn't have
I'll just say.
Why can,
But they're usually pretty good, and they actually send a text message to me to tell when it's approaching.
okay, so I'll just continue writing.
Okay, and then I'll. Yeah, you know where the final report document is on the shared drive.
I have to share
Yeah.
the drive.
So, Jim, are you still online? Maybe he's muted again.
Okay, no, so I'm connected to my laptop now, so the microphone won't work anymore.
Oh, okay.
Yeah.
He is there, but
Yeah. Jim and Tim, can you hear us? Okay, so
Okay.
Jim says he can hear us.
Okay, there might be yeah, that's right, I can't hear you.
Yeah,
Hear that, you know.
we can't hear you.
So there might be a
gotta
bit of a
come
change to the
to the end
schedule.
now,
I think
so-
when Alan's done with his demo, we might talk a bit about the final report and,
No, there's time at the end of the day, so we can do that then,
okay,
which is, yeah. So
okay.
Okay,
You can take time.
I can run it now. That's gonna work. So. Do this control. Fuck's sake. Zoom in. Can you guys see, or is that too small?
Maybe a little bigger. Melissa, can you see this? That was better.
All right. So where was I? So I've shown you the data. I've shown you what kind of format it needs. Plot the data, number of trends, and I was just here. So try to run the model with only 2 common trends and one type of variance covariance matrix to show you what, the model that I had. Oh, what? Right, this is really embarrassing now. And I run this like.
I think there was an error further up.
Okay.
Like a VB line is.
Oh, okay, no. I know why. I've changed the. Okay. Right.
Yeah.
Actually, if we could quickly circulate the beverage thing, and then I'll take that letter and the beverage order down.
Take it down for you if you tell me where to take it.
Oh, no, I'll take it down and then I'll pay.
Oh, I would say.
Thanks for your help.
See you, man.
Yeah, we're gonna touch, you know, especially great on this first.
Well, first, it's right that nature creek.
That's right. That goes right here.
Yeah, all right.
Nice meeting you, Myra.
Yeah, nice meeting you too.
Yeah.
Thanks for being on the conversation. I didn't have to say. I didn't have to say anything. So I'm coming to all my workshops. We'll be in touch.
Oh, we're getting some sun finally.
Wow. Look at that.
Just as you leave.
Yeah. Yeah, it's like-
Enjoy it on your way.
Looks like it's 8 p.m. It's like 3.
Oh, really?
Yeah, have fun, everyone.
Yeah,
Nice to see you.
Thank you.
Yeah. See you, buddy. Yeah, we'll see you in, I don't know where, but. Every couple of months. The only chance. See you later. Thanks a lot.
I'll try. So Jim, if you can hear us, we got a rainbow and sunset at the same time.
Okay, so the list went, it's over here. Okay, so.
Sorry, Alan, we got a bit distracted.
Yeah, I guess a rainbow is a,
We haven't seen some yet.
yeah.
What's that?
It's code that works.
Yeah.
Well, what's the time
Whoa, rainbow.
Yeah.
No, I'm
Hitting that boat too, right on the boat.
It's the pot of gold.
probably just hit down.
It is. Yeah, that's right there.
Okay, yeah.
Oh,
well, it was just great.
Yeah, it was great.
We'll be in touch on
Just like you, Jim.
Even the locals, it's a good sign.
Alan, what drink shall I pick? Well, both actually. What drink do you want? I'm right
Uh, can I get a latte?
A latte.
Latte, yeah.
2 lattes.
I reckon you could run to the bottom of the rainbow.
Yeah.
Go and find the gold. Yeah, absolutely. It's got
Just take our working group picture.
Hey, Alan, surf's up. Surf's up, Alan.
Sorry?
Surf's up.
Yeah,
Yeah, hold on.
No? Yeah, Paul.
Look at this.
Wait, I don't see the rainbow.
Oh wow, let's take a picture of the rainbow behind. You got the rainbow? Yeah, kind of. Not very well.
We're really emphasizing to see this.
That's right.
Like,
Maybe this workshop is lucky.
I'm glad all the
Chasing
people
unicorns.
paying us left. It's worked.
I wonder, that is impressive. That's quite impressive. I wonder if those wind turbines shut down when they're powering too much electricity to the grid.
They shut down when
Hmm?
they didn't back.
Oh.
It's a double rainbow.
Yeah, if you get a big storm.
Because there's a few of them turning out there, but it's hard to believe there would be such a localized, you know.
So I tried to use Mars,
It's
but
double
I don't know,
rainbow.
it was so slow. That's why I
There's a
ended
double,
up using,
right?
I don't know, I wasn't doing dynamic
So
factor analysis, but
if you run that model with
Uh-huh.
several possible common trends and several variance covariance metrics, it takes a long time to run.
yeah.
Yeah.
Because mine took longer than using JAX, which is like a Bayesian model. But I don't know, now that they made a new package, I wonder if they made it faster?
Yeah, I mean,
Do you know
You
if they
really need to get
sped it up
outside
at all?
somehow to get
Yeah.
it bigger. On top of it.
Oh.
oh, okay.
Jim, I can ask you when I'm back in Seattle.
If you can hear us.
I guess once I'm done showing the code, we can maybe switch back to the desktop
Okay.
computer and then we can discuss.
Yeah.
Okay.
If you don't.
It's hard to see exactly
Yeah.
where it's kind of touching down, right? If it is at all.
Yeah, I couldn't get my model to converge in Mars. I tried to do it as a comparison of the Bayesian model, and it just ran for hours and never finished anything.
Yeah. I guess it's hard to compete with the rainbow when you try to show some arc code.
Oh, wow. That didn't sound good.
should rename it, called the Rainbow Workshop.
You ever seen that thing on YouTube where somebody saw like a double rainbow and just got, it's like a black hippie in California, just got totally freaked out. Whoa, double rainbow, man!
This stuff is really,
Yeah.
this stuff is really strong.
Well, Jim, I also wanted to ask you, because I think you were the one that told Cecilia to use my model, so you must have some thoughts about my model versus your model that you did with Carolina.
She told you we're taking rainbow big.
Okay.
We'll probably start in like another.
My code isn't in a friendly format either, which is why she had to rewrite it in Python. So I'm not sure that helped.
That's what I was saying. There is a stairs that goes up there. The door is locked. Especially around, exam time.
Because the pony is the.
Students can get pretty stressed out at exam time,
Just got the data explanation now.
Oh, yeah.
Are we ready?
I
Okay, should we start again?
Floors to find a bathroom. None, I still had to wait.
Okay. I think we'll try to start again. All right. That's our rainbow break.
A rainbow quota.
Okay, so I've just run the model with only 2 common trends and 1 variance-convariance matrix structure, which was my best models I identified previously, so I just run this one just to save time. If you have several models, you can compute the AIC and print a model table. So in that case, I only have 1 model, so I only have, well, actually I've got 2 models. I've got one with 1 trend, because I run up to 2 trends, but you can see this one is unsurprisingly the better one, but you can select your best model. Once you've done that, so you extract your best model, you run this varimax function, which estimates the factor loadings. You then rotate to get the factor loadings and your trends as well. So I'll plot the factor loadings first. So this is what you get, which is what I showed you yesterday. You can also set what level of factor loading you want. So this one, for example, is very small. So you can choose to not show anything that's below 0.05 for example. The next bit of code plots the trends. Which is again what I showed yesterday. So you've got that trend 2 actually, which was my common trend in the model. To plot the model fits, so there's this get DFA fits, which is a new function actually. It was not there in the previous version of the package. So it generates the model fit for each substock using your DFA model, and so basically that plots the model fits on top of the data you input. So that's how you get your model fits. So now that's the model without any covariate in it. So you can add a covariate, which is something that I've tried. So first, I'm gonna have to, I hope that's the right one. Yeah, so I'm loading my temperature time series, so it's pretty much just a series of value which I input in the model, and then I run another model and I put my temperature time series as a covariate in this model, which is what I've done. And if I compare using the AIC again, I compare this model with temperature to the previous one I ran. And I should get, what was that? Oh, sorry. Okay. I don't know what that took some time, but that's the, actually didn't print the table, only the AIC, but that's to show that the model I showed you previously, which didn't have temperature in it, as a smaller AIC that the model with temperature. And just to show you, if I plot, so if you repeat your varimax function and your rotation, and you plot the model with temperature, so that's the trend model with temperature, and it's I just want to show you that that's both. So it's a bit lower. I'm not sure why is that, but you can see that the trend is very similar in both cases. At least trend 2, which is our common trend in that case. And as the factor loading is also that with temperature, that's without temperature. So again, quite kind of similar between the two of them.
Sorry, which one is it?
That's, I should put something on the axis. That's the one without temperature. I think the one with temperature. Yeah, did I have anything else to show?
Should those trends be scaled to 0, or like why was the one with temperature all below 0?
To be honest with you, I don't remember. It's some code I wrote like a few years ago now, and I have to re-dive into that book and the literature to better understand. But I think. Okay, so Jim has some comments, so I suggest that we switch back to that other computer, so they can hear us. So they won't be able to see the screen and the code, but it's, if you want to see the code, it's on the Google Drive anyway. So.
Anyway.
I wanted to ask Alan a question when he's done.
Yeah. Okay, so then. Okay, Jim and Tim, can you hear us?
Yeah, I can hear you. Can you hear me?
Yeah, okay, so we're back on the main PC now, so we can now hear you.
Well, yeah, there were 3 things that I was kind of typing in the notes on the side, but, one, I don't know if it's come up, but, we can now do sort of spatial versions of this, like spatial dynamic factor analysis, and I don't know if anybody are you, Paul, or Christine, or either of you presenting that? I forget.
I don't think so.
Oh, I presented the results yesterday, but didn't really go through the methods.
Yeah, and anyway, I mean, so we could do some of the same sort of spatial synchrony stuff. And I'd love to follow up on that. And then, in terms of the Mars package, Eric Ward and I were doing some side-by-side comparisons of TMB and Mars, and what I thought was the most concerning was the fact that Mars would sometimes think it was converged when in fact you could show it wasn't. So there's code floating around to re-implement Mars in TMB, but I'd be kind of cautious using the vanilla Mars for complicated models. And then finally, I'm sorry that I didn't get to see what you presented, Alan. But in terms of rotations, sometimes you can also get a good. You can visualize. You can answer a different set of questions using a different rotation than Varimax. So if your question is about what's sort of the dominant pattern, in, size variation in a region, you don't want to use Varimax because that will come up with a bunch of rotations that explain, roughly similar amounts of variance. So instead, if you want to do something like a scree plot to figure out what's sort of the number of factors that explain the majority of variance and which are the most important, you can do a different set of rotations. I can talk about that in detail if anybody's interested. Yeah.
Okay, yeah, thank you. I mean, to be able to do the same analysis spatially, I think would be interesting for what we're trying to achieve here.
Yeah, and Jin Gao and I and some others are working on a version doing condition and estimating biomass density at the same time and looking at the covariance between those, which we interpret as density dependence. And then we've been talking, Christine and I, and others have been talking about doing the same thing for that length at one or a few ages, simultaneous with estimating biomass, and again, interpreting as density dependence. So I think that's, another direction that I hadn't seen anybody go in that, in that time series way, but somebody could, is jointly model total abundance with, their life history parameters to get density dependence.
Alan, I was going to ask, when we started doing a similar thing, which I think you and I were like doing this at the same time, just at different places. We were going to try and identify like why certain species were synchronous and others weren't, and I was wondering if you had any ideas. It's probably in your paper, but it's been a while since I looked at it. On why like the species that you saw that have shared loadings were shared, and if they had any sort of common life history traits or reasons why you think they would respond similarly.
Well, actually, the species that were consistent with the common trend. We had species with different life histories, which is what was really interesting. But on the opposite side, we had code not conforming to that common trend, where haddock was. So we've got two gadoid species. They're quite similar. I'm not sure if haddock is the best example because it feeds on benthos, but whiting is piscivorous, just like cod. And whiting conformed to that common trend really well, but cod didn't at all. So there's something else going on that I haven't been able to assess.
We found the same thing on the west coast. Cod sticks out in almost the same magnitude and shape.
Well, you could verify that by including life history traits and doing some other multivariate analysis to see if there's anything that's common.
Yeah, there's Ovaskainen has done a bunch of really interesting work. He has a 2017 ecology letters paper about modeling the covariance of a factor model as a function of traits. And so I'll try to send on the chat a link to that, but I think that's the best analysis I've seen for model-based analyses of traits and covariance.
What was his name? Sorry.
Also, Ovaskainen in Finland. It's a 2017 ecology letters paper.
Okay. Could you put this paper on the shared drive? I think you have access.
I don't know where it is, but I just sent you the link on the chat bar.
All right. Okay.
I don't know where the shared drive is just for a moment.
Okay.
It should be in your, like, it's a Google Drive, so I mean when you go into your Google Drive, it should say like Aberdeen meeting 2018.
Yeah, here I'm looking right now.
Okay.
Alan, so from more theory perspective, do you know which traits are more likely to have synchrony when you increase temperature? Say because they do have a different thermal preference, of course, most of the species. Is it known?
Yeah, so they do have different temperature preference. So in that case, for haddock, for instance, which is a boreal species, we only find it in the northern North Sea, and it conforms to the common trend. But then we have at the same time in the southern North Sea, which is warmer but shows the same trend in temperature, other species with a different thermal preferences showing the same synchrony and trend in L infinity, just because they've been subject to the same trend in temperature.
And is it the same for growth, the K you say?
Yeah, so so I only look at L infinity, but the K and L infinity are they're highly correlated, inversely correlated.
Yeah,
Yeah.
Jim, can I ask you about the spatial dynamic factor analysis? Presumably you have to choose an appropriate scale, and I guess that would have to be large when you're dealing with data sets like this, would it?
Yeah, so I usually analyze the Eastern Bering Sea first because it's a shelf ecosystem that has a dominant scale that occurs at the scale of sampling. And when I end up doing these spatial analyses of ecosystems with a strong slope like the California Current or the Gulf of Alaska, they end up looking a lot uglier for the reason you're saying. I think with increased computational power, eventually we'll be able, hopefully soon we'll be able to do, multi-scale models for slope ecosystems too. And as a final point, we've got a PhD student, John Best, who's looking at spatial non-stationarity, so modeling covariates on the spatial scale parameter. Under the theory that maybe as things go deeper, it becomes more spatially homogeneous or whatnot. So I hope we can make progress, but I think your point's a good one.
So you mentioned that there's a TMV version of this analysis. Is that kind of ready to go, or is that in the works? Or?
So there's a bunch of people that have talked about it. I built it kind of independently. I think that Tim Klein was talking about having a version that was sort of, had a nice interface, and then Eric Ward's been talking with Brandon Chasko about actually rebuilding the Mars package. So if you are interested, I guess feel free to email me and I can just try to make a big email thread to see who's furthest along.
Okay.
I was also thinking about recoding my state space model in TMV, so I would be interested in looking into them.
Okay. Now, Christine, the stuff you presented yesterday, was that, I thought, maybe I get confused, but I thought that was kind of like the generic VAST package. But is that like a spatial factor analysis, or are those the same thing? Or
no, it's the VAST package.
Okay, gotcha.
It's not the delta part is turned off, so it's just the continuous part.
Okay.
Of the VAST package, not the zero inflated part. And I haven't shown Jim the latest results.
And you're running at age.
And I picked one age for each species.
Yeah. Yep. Jim might get an idea. I just saw his comment.
Well, yeah, we're
What's that? What's that?
It was his idea, so we should like it.
I thought he said, I wish I would have thought that first.
The state space model, yes.
Okay.
Yeah, he was talking about the state space model.
Okay, sorry, misread it. Okay.
Any more question about the analysis?
That was a great demonstration.
Okay.
I think you wouldn't work for the thing kind of fly.
Yeah.
Switch computers and switch communication software and all that stuff. So.
Yeah, yes. So it was a bit tedious at the beginning, but yeah, managed in the end. So anyway, it's on the shared drive with the documentation if you want to have a look.
Okay. So Jim, we're gonna take another break. So we have a scheduled like tea and coffee break. We might come back in about 15 minutes or so.
Yeah, here, I'm just working